Alright, so to finish up our last chapter in organic chemistry, we're going to talk about all the different other structures that you can have with alkenes and alkynes and alkanes. Okay, so first we have an aromatic hydrocarbon. Aromatic is called that because they emerge pleasant odors, smells, they smell nice. So some examples would be like wintergreen extract, cinnamon extract, vanilla extract. Any kind of extract is actually a hydrocarbon. So there you go. One type of aromatic hydrocarbon is a benzene ring. Every single one has a benzene ring from the previous slide. The benzene ring has a formula of C6H6 and has a planar, which means it's flat, structure in which all the bond angles are 120 degrees. Because benzene has staggered double bonds between between the carbons, so there's a double bond, no double bond, double bond, no double bond, double bond, no double bond. It could be this structure, or it could be this structure. We don't really know. So in order to signify that it's somewhere like that, we just put a circle inside of the hexagon for that ring. So if you ever see something with that circle, that would be a benzene. So to name an aromatic carbon, the substituted benzene molecules are formed by replacing one or more of the hydrogen atoms on the benzene ring with other atoms or groups of atoms. So just like before, we could have chloros, we could have bromos, we could have methyls, all that kind of stuff. Monosubstituted benzene would mean that we can use the substituent name as a prefix of the benzene. So if there's one chlorine, we could just use chlorobenzene, because since it's in a ring, we don't really have to count necessarily. Or this one would be ethyl benzene because it has an ethyl group off of it. Some other common names, so like chlorobenzene for the chlorine. If you have an OH group, an alcohol group is what that's actually called, we call that phenyl. Toluene is when you have a methyl group off of it. Nitrobenzene is when you have an NO2. And bromobenzene is when you have a Br, bromine. Styrene has the ethyl group coming off of it. It's actually kind of like an ethene group coming off of it. So that's styrene with E on E to remind you about that double bond. You could also use a benzene ring as a substituent as well. And when it happens like that, you call it a phenyl group. So it's coming off of the chain. So we would say that this is, if this is carbon 1, 2, 3, 4, we would say that this is on that chain. Three phenyl, 1 butene. When you have two things substituted, it becomes a little bit more difficult. Because they could be right next to each other, they could be across from each other, they could be one step away from each other. So, for example, this is 1,2-dichlorobenzene because we would just pick that one of them and the other one's 2, or 1 and 2. And so we can number it just like we've been doing. Another naming system that we have when we have benzenes is when we use ortho, meta, and para. Ortho is when they're close together, like directly next to each other. Meta is when they have one carbon empty between them, and para is when they have opposite each other. So this one can be called ortho-dichlorobenzene because we have two chlorines, so that's why it's di, and then they're ortho, they're right adjacent to each other. Or to simplify that even further, you can just put O-diachlorobenzene. So for example 7, let's name these compounds. Let's use the meta, ortho, and para way of doing things. Okay? So the benzene is kind of in the middle, so we're just going to keep that as our base for both of these. So we have two groups coming off the first one. We have we have a methane or methyl group, and we have a bromo group, bromine. All right, so we are going to name this. We have two different ways to name this, okay? We can use the bromo as the prefix to the word, just like up above in the common non-substituted benzenes. So we could have bromobenzene. And then we need to number the methyl. So if we're saying bromobenzene, that's saying that we're going to put this at 1, 2, 3, 4, 5, 6. Each point is a carbon. Okay, so then the methyl would be on the 3, so it would be 3-methyl bromobenzene. Or, if we didn't want to use the numbers and we wanted to use the MOP system, these have one carbon separating them. They're not adjacent, and they're not directly across from each other, so this would be the meta way. Okay, so then for the meta, we would put it as M stands for meta, methyl bromobenzene, or there's one other way with the meta. If you look up at the top table, we also have something when you have a methyl group coming off, and we could call that a toluene when we have the methyl group. So instead of having bromobenzene, we could use toluene instead, and we can call this M for meta, bromo toluene. So all three of those names would be correct. Any one of those would be correct to me. Okay? For the next one, same thing applies. We have many different names. We have the OH group, and we have the Br group. So if they're adjacent with each other, we could use the ortho, and we could call this O. We have a bromine, so that could be bromo. And at the top, if you have an OH group, it's called a phenyl, so it could be O, bromo, phenyl. Or you can name it like 1, 2, and then you would have 2 bromophenyl. We also could use the bromobenzene with this, but to save time, I'm just gonna not go through that. These are some more complex aromatic compounds. You won't ever have to identify these, but if you ever heard of naphthalene before, it stinks. It really stinks. It's aromatic in the bad sense. Anthracene and phenanthrene are all right there, where they're connected benzene rings. So now we're on to our functional groups. We have many different functional groups that these are the addition of atoms, and they have specific functions. We're just namely going to still name them. So here's a list of all of the functional groups that we have. We have alkanes, alkenes, alkynes, all three that we've seen before. Phenyl would be the benzene. We have an alkyl halide, which means we replace the H with something else, like we've seen before. We have something called amine, an alcohol group, an ether, aldehyde, ketone, carboxylic acid, ester, and amide. So let's identify the groups that we have in this compound. Well, looking at our table that we have, and I have them all circled for you. Okay, so then starting up here, this is called a ketone. So the O is double bonded to the carbon. The next one circled over is called an amide because it has the nitrogen and it has the O. So it's called an amide. This one is not on the list, but this is called a nitro group. This is called a nitro group. We won't have to identify those. Then this one has an O in between two carbons. So this is called an ether. And over here is another amide group. This right here is actually also another ether. But they just didn't make it as nice as the other ones. So we can identify the different types of groups if we see a structure, which is one of the things we're going to do on the last assignment. So alcohols are the first group we're going to talk about, and they're characterized by having an OH group. And the systematic name for this is, instead of the E at the end, you put an OL. So like phenyl or methanol, you have the full word except that AOL at the end. And then, if necessary, you also signify where the OH group is by a number. So for like example, we have to figure out the names for these. Okay? Well, the first one's a straight chain, and since it's at the beginning of a chain, we're going to start counting closest to the OH group. So we're going to say that this is carbon 1, 2, 3, 4, 5, 6. Well, there's no double bonds at all, so we can just use the ANE ending for something with 6, which is hexane. But instead of hexane, we're going to drop off the E and have hexanol instead. And that's the name of the compound. Next we have the OH group, and it's not on the end carbon. And I know this gets confusing, but anything with a turning point is a carbon. Okay? And then also the carbons in the end. The carbons in the ends are not methyl groups because they're probably the longest chain. So we have 1, 2, 3, 4, 5 as our longest chain. We've got to start counting closer to the OH group. So this would be 1, 2, 3, 4, 5. So since there's 5, that name, and there's no double bonds, it'll be pentane, but you drop it, and you have pentanol. And since the OH group is on the second carbon, we say 2-pentanol, and that's the name. We can have primary, secondary, tertiary alcohols, and this is according to the number of hydrocarbon fragments bonded to the carbon where the OH is attached. So, like methanol, there's only one carbon, so that doesn't really count. But then you could have ethanol, which is located second, and that's a primary alcohol. Or propanol is a secondary because you have 2 on either side. And then tertiary has 3 carbons connected. So that's the most you can have is tertiary. So for examples 10, give a systematic name for each of the alcohols and specify whether it is a primary, secondary, or tertiary alcohol. So for the first one, this is a methyl group. These 2 are not. These are a part of the chain, okay? So we're going to start counting closer to the OH group. So that's going to be 1, 2, 3, 4. So we have 4 carbons. And the alcohol group is on the second carbon, so it's going to be 2-butanol. But we also have to signify our methyl group is also on the 2. So it's going to be 2-methyl 2-butanol. So 2-methyl-2-butanol will be the name of that. Well, looking at the carbon where our alcohol group is touching, we have carbons here, and carbons here. So if you have 3 carbons on that, that is a tertiary alcohol. Okay, that's how we signify if it's primary, secondary, or tertiary. Then, our other one, the OH group is on the end. So that means the carbon that it's starting with is right here. Here's another one, and there we go. So our longest chain here is going to be 1, 2, 3 long. So if it has the OH on that one, it is going to be called propanol. And since it's on the first carbon, we don't have to worry about numbering it, but we do have to include our methyl group, which is on the second carbon, so then that would be 2-methyl propanol. And on this one, since it's connected to this carbon, they don't show it, but this has the other hydrogens bonded to it. So this really only has 1 carbon off of it, so this would be called a primary alcohol. So why we have alcohols? So methanol and ethanol have great commercial value to our society today. We use them for a lot of things, including fuel. Methanol uses can be used to start the synthesis of acetic acid and many other types of adhesives. It also can be used for motor fuel for racing cars. Ethanol is used in alcoholic beverages and as a fuel source. So, the next group is our aldehydes and ketones. An aldehyde both contain what's called a carbonyl group. And ketones, so the carbonyl group is the O with double bonded to the C. So in ketones, the group is bonded to 2 carbon atoms. Like you see here. In aldehydes, it's always like, the ketone's always in like the middle of the chain. And an aldehyde is always on the end of the chain, okay? Because it has at least 1 hydrogen atom bonded to the carbon atom as well. So if you notice, ketone's in the middle, aldehyde is at the end. So how do we name them? Aldehydes have an Al at the end. I'm not editing it. I don't care. I don't have time for it. So, not going crazy. Ketones have O and E at the end of their name. So, one of these is an aldehyde, and one of these, actually they're both ketones. I lied. So, to name these compounds, we need to figure out how many carbons are in their longest chain. So, in this case, on the left side, there's 1, 2, 3. It doesn't really matter where you start counting because it's 3 either way. So that is going to be propan, and since it's an ketone, we call that one, propanone. And we number where the ketone is. So since it's on the second carbon, that will be 2-propanone. Now, for this one, we have to count, see which way is the longest chain. We're going to count closer to the ketone group. So this is the first carbon, 2, 3, 4, and 5. And you can go either 6 or you can go 6, either way. This one's going to be a methyl. So we have 6 carbons in our chain, so it's going to be hexanone for the base name. We have to number where our ketone is because that's what we always do. So it's 2-hexanone. And then we have a methyl group on the 5 carbon, so it's going to be 5-methyl 2-hexanone. Next, we have carboxylic acid and esters. carboxylic acids, you usually see a COOH group on it. It has a double bonded O with an OH on there. And esters usually have a formula where they have a double bonded O and an O without the H on it. So there we go. To name them, for carboxylic acid, you drop the final E and add OIC acid, and then they're often named as their common name. So like, if you've ever heard of acetic acid also being called ethanoic acid, it's the same thing. That's just their common name. And then an ester has ATE at the end. Okay, so last but not least, we are going to talk about polymers and two different ways to add all these chains together. So polymers are usually large, long things built from small molecules called monomers. And polymers make plastic, synthetic fibers, rubbers, anything like that, and they've been around for about the past 50 years. Best known polymer is polyethylene, where it has 2 C's and 4 H's repeating. A distant polymerization means that the polymers simply add together to make a big long chain, okay? And so usually that's like breaking double bonds into single bonds and stuff like that. Then for condensation, when they add together, they actually lose a water, an H2O. And so that usually happens when you combine alcohol groups with carboxylic acids, like shown here. All right, that's the end, and go ahead and do the rest of the homework.